Good afternoon, class. In today's video, what I wanted to go over was the two different types of waves that exist in our universe. And those two are the transverse waves and the longitudinal waves. So transverse waves are the waves you've more commonly seen throughout your life, possibly either when you've gone to the beach and seen ocean waves, or when you've seen in math sinusoidal or sine or cosine waves, basically. So these waves are transverse waves, are waves that you see that move perpendicular. Their waving motion is perpendicular to the direction of travel. So, for example, this you might get an idea for this from the ocean waves. So an ocean wave would peak over here and travel this way, but the peak moves vertically and the direction of travel is horizontal. So that would be an example of a transverse wave, at least a real life example. This is what it would look like in general. Okay. Notice though, and this is important, this does not require a medium. That's why light can travel through space. And the way we have, and the evidence that we have of that is that light must be a transverse wave, is that it goes from the sun all the way to the earth in about 8 minutes without a medium inside of there, because it's space. Outer space has no medium by definition. So now that we've covered the type of a transverse wave and a couple of examples of it, let's talk about a longitudinal wave. And that is a wave that moves parallel to the direction of travel. So what that essentially means is that it moves in the same direction as the wave is traveling in. So for example, this is how you would basically draw it out, and this is my attempt at drawing out how it would look like based on the mental picture of having a slinky. And instead of like holding the slinky and then shaking it like this, you would hold the slinky and then tap it, and so that tap goes along the slinky itself. And of course you can see that there's parts that compress a little bit more, some parts that get stretched out a little bit more, and then compressed again and do the same thing. That is essentially what a longitudinal wave would look like. So, but if you notice, this wave is traveling this way. The waving motion itself is actually traveling in the same direction as the wave packet is traveling. So that's why both of these are parallel to each other. Now this one, and this is the key thing, this one requires a medium. And an example of this is sound, because sound, I'm talking to you through, it looks like nothing, but actually there's air between my mouth and the camera. So when I'm talking, I'm vibrating air in my throat, and it's sending it out at a specific frequency that's getting recorded by this camera. That is allowing you to understand what's going on, even though and all at the same time, the transverse waves that are coming from the lights up here, reflecting off of the board and going towards the camera, all of that all those reflections are transverse waves. The sound coming from my throat is a longitudinal wave. And so one of the ways that you can, so that's one of the ways that you can think of one of the ways to think about a longitudinal wave. The other one, and I'm going to get into that in a future video, deals with music, because while sound is a great example of a longitudinal wave, for those of you who have ever watched the Aliens franchise, one of the key takeaways from that series of movies is that they would tell you, oh, in space, no one can hear you scream. And you know what? That's actually very true, because sound is a longitudinal wave. It cannot travel unless it's sent along a medium. So yeah, if there's no medium to send the signal through, no signal goes through. So that's why I could scream at the top of my lungs if I was in a spacesuit, and you could be this close to me, and I could be screaming at you at the top of my lungs, and you would hear nothing, because there is no, if there's no medium between us, you wouldn't hear it. You wouldn't be able to hear anything that would occur, or anything that would come from my throat. So there's a truth to that. It's supposed to sound scary, I know, but it was one of those movies when I first saw it come out, and they had that line. I said, oh, That's actually correct. Like that is a true statement. So there's that. I mean, there are some examples either in pop culture and also through our everyday interactions where you've seen transverse waves and longitudinal waves. So in the next next set of videos, I'm going to start going into each of these different types of transverse waves and longitudinal waves. Most importantly, light and sound. Those are the ones that are coming up next. So good luck in your studies, and may the force be with you.